and then I'll share my screen right here. Did I share my screen? Share screen, share. Okay, can you see it,
Yes.
Kaplan? All right. All right, this is just some practice with exponent laws and the roots and polynomials. So let's just go through some of these practice questions, and I think there's a quiz, a practice quiz somewhere we can take. Oh, this is a practice quiz. Okay, let's see here. Okay, so can you see this?
Yes.
All right. Which of the following is equivalent to the expression that? So how do you do that?
And you do the exponents first, and then you just parentheses, and then you divide.
Okay, so 9 to the 4 times 3 to the 2 over 9 to the 5. How do we do that? What can we simplify? How can we simplify? So we have base 9 here, we have base 3 here, and we have base 9 here. We can change them all to one base, right? So we can write them with base 3 or base 9. So what do you want to write them with the same base? We can change this one here to base 9, right? So we can leave the 9 to the 4. What's 3 squared with a base 9? 9 to the... It's just 9 to the 1, right? All right, so what's the numerator now? 9 to the 4 times 9 to the 1 is?
Um,
You just add the exponents, right?
so it's 9 to the 5,
Yep, 9 to the 5 over 9 to the 5, which is what?
1.
Yep, so that one's 1. Okay. Have you studied exponent laws?
Why would
Yeah, okay. All right, this is a good review. All right, that one's 1. All right. Question 2. What is the resulting coefficient of x after multiplying that by that? So it's just really a distribution, what do you call it? Distributive law. So negative x plus 4 times x minus 5. So how do we do that one? Just distribute, right? That one times that one times that one, these two, and these two, right? Now, actually, this missed this part right here. What is the resulting coefficient of x? What does that mean? What does coefficient mean? So for example, 9x, what's the coefficient?
X,
9. It's the number beside the variable. So what's the coefficient on this one?
5,
5, yep. What's the coefficient on this one?
-1.
Negative 1, yep, okay. So we're going to multiply this out and then check what the coefficient of x is, okay? So what's negative x times x?
Negative x squared.
Negative x squared, good. That's the first ones multiplied by each other. Now the outside ones multiplied by each other, negative x and negative 5.
Positive 5x.
Yep, plus 5x, okay. The middle two terms, 4 and x, plus 4x,
4,
yeah. And then the last term, 4 times negative 5,
-20.
negative 20. Okay, now just clean up the middle term, 5x plus 4x.
9x.
Okay, so what's the coefficient? So what's the answer to the question they're asking? What is the resulting coefficient of x after multiplying? This one's x squared, this one's x, and this is just a number, right?
So it's 9.
9, exactly. The coefficient of the x is 9. Yep. Yep. Okay. All right. That's 2. 3. All right. Read 3 for me.
The power generated by a windmill is related to the velocity of the wind by the equation shown, where P is the power in watts and This
Yeah, vis and vis, the wind velocity. Not sure what that is.
miles per hour. What is the wind velocity when the windmill is generating 160 watts of power?
Power. All right, where's the formula? Did they give us a formula? The power generated by the windmill is related to the velocity of the wind by the equation shown. Where is what equation? What equation? Oh, it's this equation right here. Oh no. I don't even see the equation. Let's see answer 3. Um, okay, we don't even see the equation on that one. Let's skip that one. Okay, let's skip that one. Let's go to 4. The length of box, which shows the difference in volume of boxes. What are they referring to? Okay, let's see if we can do 4. The length of box 2, y, shown above is twice the length of box 1, x. Which expression shows the difference in the volumes of the two boxes? Okay, so it's asking kind of two things there. Well, not asking two things, but you know how to calculate, you know what a box looks like, right? A cube.
Yeah.
Just like, box 1's like that. And then box 2 is something just like that, a different size though. The length of box 2 shown above is twice the length of box 1. Which expression shows the difference in volumes of the two boxes? Okay. All right, so there's your box 1. The length of box, so this part right here is the length of the box, right? So there's your length L1. The length of box 1 shown above is twice the length of box 1. So this is box 1, right? This is no, this is box 2. This is box 2 and box 1. So box 1's about half the size, or half the length, I meant. Okay. So this is your L1, right? This distance right here is your L1 on box 2, box 1. So how do we find the volume on boxes? Or how do we find the volume on a cube? This is just a cube, right? How do we find the volume on those?
Length times width times height.
Exactly. Length times width times height. And then same thing with this one, right? Volume equals length times width times height. All right, so now we know these lengths are related. Which one's bigger?
Box 2.
Okay, so what variable can we put for L1? What variable can we put here? What variable could we put here? The length of box 2 is shown. So this will be 2x here, right? Twice, and then this one be x. Because this first sentence right here, the length of box 2 shown is twice the length right here, twice the length of box 1. So we're going to say box 1 length is x, box 2 length is 2x. Okay. Which expression shows the difference in volumes? What operation is difference?
Subtraction.
Subtraction. Okay, so let's put some numbers in here. If that's x, that's 2x. If this is 3 and this is 5, if this is 3 and this is 5, what's the volume on this one in terms of x? Just multiply these. 2x times 3 times 5. That's what, 30x? Yeah, 30x, right? So what's the volume of this second one in terms of x?
15.
15x. Okay, so now that's the volume. Which expression shows the difference in the volumes of the two boxes? All right, so if we subtract them, it'll be 30x minus 15x. But I think from the diagram that we don't see, they're giving you these numbers. They're giving you these numbers, but we don't see the diagram, right? I don't see the diagram. All right, maybe we should skip that one too, because I don't see the diagram on that one either. All right. All right, that was a bad question because we don't see the diagram. All right, that was it. All right, let's just go to actually let me press start quiz, maybe that's why. All right, let's go to the eraser. Basically, box 2 is double the volume of the first box. All right, let's just press start quiz and see what they got. All right, that one we did. That one we did. Okay, here's the okay, my bad. Here's the formula. All right, let's try number 3. The power generated by a windmill is related to the velocity of the wind by equation shown, where P is the power in watts and V is the wind velocity in miles per hour. What is the wind velocity when the windmill is generating 160 watts of power? So where do we plug in the 160?
P.
Yep, so just erase that and plug in 160 right there. Okay, so take your calculator or your phone, divide 160 by 2%. And then do you know how to find the cubic root of that? What's 160 divided by 2%?
8,000.
8,000. Okay, so what number times itself 3 times is 8,000? Maybe, I think it's 20. Right here are your answers, right down here. So if we say 20 times 20 times 20, is that 8,000? It's kind of like asking, is 2 times 2 times 2 8? Right? Yeah, so it should be 20. Okay. All right, number 4. Now we're going to see the boxes. Okay, here's number 4. Oh yeah, here we go. Here we go. The length of box 2. The length of box 2 shown above is twice the length of box 1. Which expression shows a difference in the volumes of the two boxes? Okay, so let's plug it in. All right, so if this is 2x right here, now we know that volume equals this number times this number times this number. So let's multiply these three together. What are these two multiplied together? Y squared minus 1 times y plus 1. What is that if we multiply that? What's that equal to? Y squared, just FOIL that out, right? Y squared minus 1, right? Now we take the y squared minus 1 and we multiply it by 2x. We're just multiplying all the three numbers together, right? So what is y squared minus 1 times 2x? What's that? Just for the distributed 2x y squared. What's the second term?
-2.
Negative 2x, yep. Okay, so that's the volume of box 2. What's the volume of box 1? So I think they're saying that this is the same thing. This length right here is the same as this. So this is y plus 1. And then this part right here is also y. The height is y plus 1 or y minus 1. So this distance right here is y minus 1. So if we multiply those two numbers together, we'll get the same thing as right here. Y squared minus 1 times x on the front. What's this one? What's the volume of this one?
XY squared.
Yep.
Minus x.
Yep. Okay, so now we take the two of those. We take this one right here. This right here, and this right here and subtract them. Which expression shows a difference in volumes of the two boxes? So the bigger one's the box 2, right? So take this one right here and subtract off this one. What's 2x squared y? What's 2xy squared minus 1xy squared?
1xy squared?
Yep. So there's your 1xy squared. And then what's negative 2x minus, there's your negative 2x minus x.
3x?
So we're doing this 2xy squared minus 2x minus this other one, xy squared minus x. So we got to multiply the negative sign into the brackets. Okay, so 2 minus 1 would be 2xy squared. Then we'll have this negative 2x here plus, right? So it'll be negative 2x plus x. What's that? That's just minus x, right? Do we have that one? No? Negative 2x plus x. No, we don't have that one. What do we do wrong there? Did we do something wrong there? Two x3 minus 2x. Or there's no y's actually. There's no y's in the answers, right? Which expression shows the difference in volumes of the two boxes? So maybe let's let's look at the answer on that one. Let's see what they did. Number 4. Find the volumes of each. Box 1 volume is x. Oh, they have y actually. They put y in the picture, not x. They meant x here, right? This should be x, x minus 1 and x plus 1. They wrote y there. So look what they wrote right here. Volume of 1 is just the 3 numbers multiplied by each other. Okay, so we'll get x cubed. So they got the wrong label in the diagram. Substitute 2x for x in the volume you already found. Okay, and then you just subtract them. Okay, so they gave us bad information. They labeled the diagram wrong. Right? All right, so let's get let's skip that. Let's skip that. All right. We didn't get we didn't get any right. I don't think we put the answer. All right, let's go to the next quiz. Your review, we get more or no? All right, let's actually go back. Let's try one of these. Polynomials. What does polynomial mean? What does this word mean right here? Polynomial. You give us a quiz here or no? No quiz? There's no quiz on that one. All right, let's go back. Maybe let's try this one. Rates, ratios, proportions, and percents. All right, got a quiz. All right, let's start this quiz right here. All right, can you read that?
During fairly heavy traffic, the number of cars that can safely pass through a stoplight during a left turn signal is directly proportional to the length of time in seconds that the signal is green. If 9 cars can safely pass through a light that lasts 36 seconds, how many cars can safely pass through a light that lasts 24 seconds?
So how do we do that? Set up our ratio. So 9 cars in 36 seconds. It has to be the same ratio. Equals what? What over what?
Um, X cars over 24 seconds.
Yeah, X there, X cars, and 24 seconds. Yep. Now just solve that for X. So just cross multiply there. These two times each other equal these two times each other. So 36X equals, what's 9 times 24?
260.
260, and then divide that by 36.
6.
6. Okay, so that one's 6. Okay. That one's easy. All right. That was 1. Let's submit 6. According to data, okay, you read it.
According to data provided by the College Board, the cost of tuition and fees for a private nonprofit four-year college in 1988 was approximately $15,800 in 2013 dollars. In 2013, the cost of tuition and fees at the same type of college was approximately $30,100. If the cost of education experiences the same total percent increase over the next 25 years, approximately how much will tuition and fees at a private nonprofit four-year college cost in 2013?
Okay. So in 1988, it's this much. 1988 is this much. 2013 cost tuition fees team. Now it's this much. Okay, so to 1988, it's 15,000. In 2013, it's 30,000. If the cost of education experiences the same total percent increase over the next 25 years, approximately how much will tuition and fees at a private nonprofit cost in 2013 dollars? Okay, how do we do that? So, okay, so it went from 15,800 to 30,100, right? What percentage increase is that? How do we calculate the percentage increase?
Um, Divide
Divide which one? What number on top, what number on the bottom?
15,800 on top and then 3,100 on the bottom.
The other way, 13,100 on top and 15,800 on the bottom. What percentage is this? It's about what we're now put this answer in terms of percentage. So percentage.
Hmm,
What decimal number did you get?
1.94.
05. Yep. Now take that number and multiply that by 100. That would be your percentage increase. So about 190.5% increase. Okay. So it went up almost double. Okay, almost double. Okay, so now it's going from 30,100. Now it's increasing again, another 190.5%. So what number do we multiply this by to get the answer? What number goes right here?
190.5.
That would actually be the decimal number. You multiply when you divide this right here, you get 0.1905, right? Let me see here. Let me go back. Undo. Actually, let me show you like this. Actually, let me do this. Let me do it step by step. So when you divide it, it's 1.905, right? 1.905, right? But that's really the same thing as 190.5%, right? Percent. What we're gonna do is take that 30,000. Are we gonna multiply by the 190% or the 1.905?
1.905.
Yeah. Okay, so take the 30,100 and multiply that by 1.905. And what number do you get?
50,340. Well, 57,340.
So about this one, right? This one right here, the third one. Okay, so let's try that one. Why would it be? Why did I say it's 30,000 over 15,000 and not 15,000 over 30,000? Why did we say it was this one? Why was it that one and not that one?
Mm.
Remember, percentage increase means it's getting bigger and bigger and bigger, right? This would be about two, right? And this would be about half, right? So it's not this one because the number would be getting smaller and smaller and smaller. If we take our 1.9 or about two and multiply, that number's getting bigger. So it's got to be, it's likely C. Let's see here, C. Yep, right? See, there's your 90%. They did a little bit different. They took the difference, then they divided by the original. Same idea, same idea. Okay. You studied percentage increase, decrease before?
Yes.
Yeah. It's kind of like if you take five tests in school, right? Test one, test two, test three, test four, test five. Say you get 80% on the first one, or say you get 80 on the first one, say you get 75 on the second one, 88 on the third one, 92, and then 60. Okay, so between these two, you'll have a percentage decrease. Between these two, you have a percentage increase, percentage decrease, right? Between each test. But what if I wanted to ask you, what was the percentage decrease on test one to test five? What's that percentage decrease? Question mark. How would you find that? What's the difference? What's the percentage decrease between 80 and 60? How do we find that?
Divide 60 by 80.
60 by 80 is what? 75%. 75%, which is 0.75. 0.75. So would it be a 75% decrease? %75 decrease is a lot, right? But in that case, you would take the difference. You take the difference, 80 minus 20, and then divide that by 80. So it's really 1/4. Really 1/4. All right, let's get back to this. Okay, number 3. Can you read 3?
A chef is preparing ingredients to make a large quiche. The recipe calls for 5 cups of milk and 2 eggs. There's also a lower fat option that calls for 4 cups of water and 3 eggs. The caterer wants to see what happens when he uses both milk and water. To keep the same ratio of liquid to eggs, what ratio of milk to water should he use?
Okay, so how do we do that one? Recipe calls for 5 cups of milk for every 2 cups of, or no, for every 2 eggs, right? Recipe calls for 5 cups of milk. So if there's your 5 milks and there's your 2 eggs, there's also a lower fat option that calls for 4 cups of milk. Oh, no, 4 cups of water, 4 water and 3 eggs. The caterer wants to see what happens when he uses both milk and water. The caterer wants to see what happens when he uses both milk and water. To keep the same ratio of liquid to eggs, What ratio of milk to water should he use? How do we do this one? This is milk. This is water. To see, the kidder wants to see what happens when he uses both milk and water. To keep the same ratio of liquid to eggs, what ratio of milk to water? What's that one? That option that calls for 4 cups of water and 3 eggs. Liquid to eggs. What ratio of milk to water should he use? Okay, so we see our two fractions, right? 5/2 and 4/3. What now? These are different denominators, right? So we want the LCD, lowest common denominator. What's the LCD in that case?
6.
6. Yep. So what's this fraction over 6? And what's this fraction over 6?
15 over 6, and then
Yep.
8 over 6.
Yes. So is that this last one right here, 15/8. Okay. It's basically asking what those numbers are, 15 to 8. Okay. All right. 15 to 8, that one. Okay, good. All right, Cyber Cafe.
A cyber cafe is a place that provides internet access to the public, usually for a fee, along with snacks and drinks. Suppose a cyber cafe charges a base rate of $25 to join for a year, an additional 30 cents per visit for the first 50 visits, and 10 cents for every visit after that. How much does the cyber cafe charge for a year in which 72 visits are made?
Okay, so how much for 72 visits? So tell me what to write here.
So $25.
25 to join, yeah. Plus,
30 cents for the first 50 visits.
okay, so 30 cents, 0.3 for the first 50, right? 30 cents for the first 50 visits. Now we got 22 visits to go. And 10 cents, 0.1. 72 minus 50 is how much?
22.
22. So for 10 cents for the next 22 visits, right? All right, add this up. Add this up. How much is that? 25 plus 30% of 50 is what?
15.
15. And then 10% of 22 is what? 2.2?
Yeah.
How much is that? 42? Yeah, this one right here. 42.20. Okay. There's your 40. Those two is 40, and then 2.2, 42.2. 42.2. All right, engine oil.
Engine oil often contains additives that are designed to prevent certain common engine problems. One such additive is zinc, which reduces engine wear. Company A's oil contains 4% zinc, and Company B's oil contains 9%. Suppose a car uses 8 pints of Company B's oil and a truck uses 6 quarts of Company A's oil. How many times more zinc is in the car's oil than the truck's?
Okay, so how do we do this one? Okay, once a zinc, which reduces engine wear, companies A and B. Company A's oil contains 4% zinc and B's 9%. Okay. Suppose a car uses 8 pints of company B's oil. So 8 pints. And a truck uses 6 quarts of company A's oil. How many times more zinc is in the car's oil pan than in trucks? So this is the car here, and this is the truck. All right, so how do we do that one?
Well,
We know that one
convert
quart
them
is
to
two
the
pints.
same units.
Yeah, okay, so let's convert. So you want to convert the quarts to pints or the pints to quarts? How many pints is this quart, 6 quarts?
12.
6 quarts would be 12 pints. Yep, 12 pints. All right, now what? How many more times zinc is in the car's oil pan than in the truck's? So basically compare these two numbers, that and that. So what you're doing, so what are we doing with the 8 and the 12 and the 4 and the 9? 4% and 9%. Just multiply. Take your 12 times 0.04, 0.04. Find out what that is. What is that? The 3, 0.3.
0.48.
Oh yeah, I can't even multiply. Yeah, 0.048. Yep. And then this one, do your 8 times 0.09. What's that? 0.72. The 0.72.
Yeah, 0.72.
0.72.
Yeah.
All right. So now you compare these two numbers right here. How much more, right? What operation is how much more? How many actually no, my bad. How many more times? How many more times? Zinc is in the car's oil pan. How much more is this than this? So compare these two numbers. How much more is this 0.72 than the 0.48?
124.
Say it again.
0.24.
How you getting that? Not the difference. Not the difference. See this last question right here? How many more times? How many times more zinc? How many times more zinc is this one than this one? Just divide it. 0.72 times 0.48. That should be 3.
I got 1.5.
No, 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 my bad. Yeah, 1.5. Yep, 1.5. So let's pick the 1.5. Yep, there you go. I misread it the first time. I was thinking how many more, but they say how many times more. That would be division or multiplication. You could take this one and multiply by 3 to get this one, or take this one and divide by, not 3. I keep saying 3. You could take the 0.48 and multiply by 1.5, you'll get the 0.72, or you could take the 0.72 and divide by 1.5, and you'll get 0.48. Eraser. Do you guys do PSAT practice in class, in school?
Not really.
No? So they just leave you guys on your own
Yeah.
to study for it? All right, let me go back to the other section. All right, maybe this last one we'll do today. Percentages. All right, we have a quiz here. No quiz. Oh, that was the quiz. All 3 topics are in that one. Okay, yeah, it's the same quiz. All right, let's try one of these other ones. Equations and word problem. Let's try that one. All right, let's take this quiz. All right, solve that for x. Can you write on the screen? If you need to write on the screen, write on the screen.
Did you distribute the -2 first, or do you
Yep,
subtract
yep.
it?
Distribute the -2 first. Yep.
So it's the last one.
Yeah, last one looks like the last one. Yep, good. All right, Jacques Charles was a French scientist who discovered the relationship between temperature and volume of gas. Specifically, Charles found that gases expand when heated. This relationship was formalized in Charles's law, which illustrates the linear relationship between temperature and volume in gases. The graph here shows the volume of a sample of gas as it is cooled. If T is the temperature of the gas in degrees Celsius and V is the volume in liters, which of the following equations was plotted, when plotted, could produce the graph shown? So they give us the graph. There's the graph. Okay, so which one of these is that graph? Okay, you remember your y equals mx plus b slope y-intercept form? Remember that? B is the y-intercept, right? B is the y-intercept, and m is the slope, right? So use that same setup for this graph. So ask yourself, if you were to extend this line, where would this line intersect the y-axis? What point approximately is that? That will be the number on the end here. So it's not plus 100. It's not plus 0. That wouldn't be plus 0. It's not that one. Plus 1. 1 was up here. 1's right there. So it's not that one. So I'm guessing it's this one right here. D. And the 0.004 will be the slope. All right. So that one we could just use the process of elimination. Right? Just eliminate the ones that don't make sense. So I'm thinking D. Let's try D. Oh, no, I'm wrong. Which one? This is what I'm thinking here. This is your y equals mx plus b. They're saying C. They're saying C. They're saying this one. Oh, I guess I can't redo it. I'm thinking, why is it? Oh, okay. Okay, they moved on. All right, what's this one?
Miss Walter's class had 18 students. She used 3 equally weighted tests to determine. She used 3 equally weighted tests to determine their final grades. The class average for the first test was 92, and the class average for the second test was 77. If the overall class average was 84, what was the average score for the third test?
Okay. Yep. So how do we do this one? You know how to calculate average, right?
Yeah.
Okay, first test, what was the score on the first test?
92.
92. What was the score on the second test?
77.
We're going to say X is the third test, right? Okay, so now all three tests, what was the average?
84.
Okay, so how do you calculate average? You add up the three numbers, and what number do you divide by?
Divide by the number of numbers, so 3.
Yep. Okay, so there's your equation. Can you solve that for x right there? What's 92 plus 77? 169? Yeah, 169. So we got 169 plus x over 3 equals 84. How do we solve that for x? Just cross multiply. This is 84 over 1, right? Over 1. So just cross multiply these two times each other equal these two times each other. So 169 plus x. What's 84 times 3?
252.
252. So now he has to okay, so solve this one for x now. X equals what? 252 minus 169, how much?
83.
83. So C. 83. Yeah, that seems right. Okay. 83. There you go. You might get a question like this on the test. They give you the first two averages. They don't know they don't tell you what the third is average is, but they tell you what the overall average is. So then you just kind of work backwards. So now look, if you added up, oh, I can't. Oh, let me go previous. If you added up the 83, so now let's check this. Let's check this for real. If you added up the 92, the 77, and the 83, does that equal 84 average?
Yes.
Yeah, so that's like a quick way of checking. All right, next. All right. How do you do this one?
A certain gym sells 2 membership packages. The first package, the Die Hard package, costs $250 for 6 months of unlimited use. The second package, the personal package, costs $130 initially, plus 4 each day the member visits. How many visits would a person need to use for each package to cost the same amount of over a 6-month period?
Okay, how do we do that? Package 1, package 2. This is 250 for 6 months. 250 per 6 months. This one is 130 plus 4 times x, right? 4 times x is the number of visits, right? $4 times the number of visits, right? 130 initially plus $4 each day the member goes there, right? All right, so how do we find how many visits will the person need to use for the package to cost the same amount over 6 months? Okay, so what do we do now? We just equate these two and then solve for x. Okay, so solve that for x. This would be what, 4x on that side equals what? 120. 120. So x would be 30. Think of that one. Okay. 30. You just let them equal each other. 30. Yep. 5. All right. Municipality.
A municipality charges 2 types of local taxes: a per capita tax, which is a flat fee that every person pays, and a local income tax, which is a percentage of the person's annual income. I. If a taxpayer's total tax bill is given by the function T equals 0.02 plus 25, then the value 0.02 best represents which of the following?
Okay. Yeah, which one? Total per capita tax, taxpayers' annual income, total tax bill minus the per capita tax, the amount of income tax as a percentage. Which one? So one of the taxes is a flat fee, and then the other tax is a variable fee, right? Per capita tax is a flat fee. Then the other one is a income tax. That one's dependent on your income. I percentage of the person's annual income. So it should be this one. Taxpayer's annual income. You take the 2% of whatever that person earns, and then you add that to 25, and that's their tax. Okay, so it should be B. Oh no, I'm wrong. Which one they're saying D? The amount of income tax as a percentage. The amount of income tax as a percentage. They're saying D. Okay, my mistake. D. We we got two wrong. Which one did we get? What was the other one that we got wrong? Oh, this one, this question. All right. All right, let's just try a couple more. Let's go back. All right, which one did we not do? This one? This one. If if x and y are both integers such that that and that, what was the value of the two added together? All right, what's this one solve for x? What's x? X plus a 6 is 17, so what's x?
11.
And then y is what, 3 on this one? So 11 plus 3, 14.
14.
Yeah, okay, good. Certain restaurant, there are 25 tables, and each table has either 2 or 4 chairs. If a total of 86 chairs accompany 25 tables, how many tables have exactly 4? How do you do that? So 25 tables total. So either the 2 or 4 chairs. There's your table. There's 1 chair, 2 chairs, or 4 chairs. 1, 2, 3, 4. So how many of those 25 tables, if there's 86 chairs for the, so 80, 25 tables and 86 chairs. How many are 4? How many tables have 4 chairs? So we could say something like this. We'll set up 2 equations. We'll say so 2x plus 4y equals what?
86.
Um, no, this will be the 25. And then what's the other equation? Uh, if a total of 86 chairs accompany 25 tables, how many tables have exactly 4? What's the other equation? We got to come up with 2 equations. Uh, 86. If a total of 86 chairs. The total of 86 chairs accompany 25 tables. How many tables have exactly 4? Let's. What would the other one be? If a total of 86 chairs, so this one is 86. What's this right here? All right, let's check the answer on that one. What is that? 2? This one. Yeah, 2, this one. Okay. Let's see here. Okay, so they didn't come up with two equations. Oh no, they did. Create a system of 2 linear equations where t represents tables of with 2. Oh, okay. And the first equation should represent the total number of tables, each of 2 or 4. Okay, my bad. I got the wrong first equation. I think you were right. So x plus y would be 25, and then okay, yeah, that makes sense. So they're saying, oh, oops, my bad. I didn't mean to do that. They're saying x plus y equals 25, and then 2x plus 4y equals 86. So there's your 2 equations. All right, let's finish this one. X plus y equals 25 is the first equation. The second equation is 2x plus 4y equals 86. How do we solve this? If we take the first equation and multiply by 2, right? That's equation 1, that's equation 2. If we take the top equation and multiply by 2, what do we get?
2x plus 2y.
Yep.
X squared plus
2x plus 2y equals 50, right? And then keep the second equation, 2x plus 4y, that's a 4, equals 86. Now, do we add or subtract? We would subtract here, right? The 2x's would cancel. 2y, what's 2y minus 4y?
-2.
So negative 2y equals, what's 50 minus 86? Negative 36. No, just 36. Yeah, my bad. Yeah, negative 36. Negative 6. So what does y equal? 18, right? 18. Just divide both sides by -2. You'll get the 18. So 18. Okay. The hard part on that question is just setting up the right 2 equations. Once you get the 2 equations, you can solve it by elimination or substitution or graphing. Okay. 18. All right. All right. We're going to meet again, what, tomorrow?
Yeah.
All right. Tomorrow, if you want to, the rest of the day, just maybe pick out some questions you want to go over tomorrow, me and you, tomorrow morning, on your Khan Academy or your textbook or wherever. Okay. We'll go over some of the questions you have tomorrow. Okay.
Yeah.
All right, Ellie, I'll talk to you tomorrow.
Bye.
Okay, bye.